of both what a sum of cubes looks like and a difference of cubes. So that first one, a cubed plus b cubed, that would be a sum of cubes, two perfect cubes being added together. And you can also factor a difference of cubes, so a cubed minus b cubed. This pattern here in the parentheses is what you're going to need to memorize. Okay, so it's going to be a and b in your first parenthesis. And then in your second parenthesis, it's going to be a squared, a times b, and b squared. And we'll talk about in just a second where we get a and b from. And then that word SOAP is going to help us place our signs in the end. The letter S means that the first sign in your first parenthesis is going to be the same as what's in the problem. So if it's a plus, the first sign will be a plus. If it's a minus, the first sign will be a minus. Then the O in SOAP stands for opposite. That means your second sign, the first one, the one that goes right here in between the a squared and the a times b, if my pen will write, the one that goes right there is going to be the opposite of whatever the first sign is. Okay, so you'll have your first sign here. Your second sign goes here. And then your third sign goes here. And the AP represents your third sign because that third sign is always positive. Okay, same, opposite, always positive. The first sign will be the same as the problem. The second sign is the opposite of that sign. And then the third sign is always positive. So a clue as far as my variables and how to know if a variable is a cube is the exponent has to be divisible by 3. So like x to the third or x to the 6th or x to the 9th, okay? Those are perfect cubes because my exponent can be split into groups of 3. So we're going to start, is everybody ready? With that very first one. Okay, and again, the thing we need to make sure we recognize is that we have perfect cubes. That's why my list is going to be important if I'm not familiar with those perfect cubes. I'm just going to keep that written up on the board so we can refer to it as we go. No matter what, when we factor, what is the very first question we're supposed to ask ourselves? Do we have a GCF? Do we have a greatest common factor? Do x to the third and 8 have anything in common that I can pull out? No. Okay. Then the second step is to recognize there are two terms and that both of those terms are perfect cubes. My x has an exponent of 3. 8 is on my perfect cube list. So they are both perfect cubes, which means I can factor whether it's addition or subtraction. Everybody ready? So let's talk about finding A and B. I always write them above my problem just so that when I go to plug them into this formula, I have them written down and I don't have to keep it in my head. So A is going to be whatever the cube root of x to the third is. If I split x to the third into 3 equal parts, what would it be? Just x. Okay, so my A value in this problem is going to be x. And then B is going to be whatever the cubed root of the second term is. If I'm not sure what the cube root of 8 is, I can look at my list and I can scroll over to the roots and it tells me that the cube root of 8 is 2. So in this case, my B is 2. Again, I like to write them down. That way when I go to plug them into my pattern, I don't have to think about them anymore. Everybody ready? So in my first parenthesis, it is just my A value first and then my B value. We said A was X, maybe. We said B was 2, and again, we don't worry about our signs until the very end. And then I set up a second parenthesis that is going to be a trinomial, 3 terms, and that is A squared. We said A was X, so if I square that, I get X squared. My middle term is going to be A times B. A is X, B is 2, X times 2 is just 2X, so that goes in the middle. And then my third term is B squared. My B value is 2. What is 2 squared? 4. So that goes in the back of the parenthesis. And once we have those values filled in, then we can go fill in our signs with SOAP. The first sign in the first parenthesis is going to be the same as what's in the problem. What's in the problem? A minus. So I'm going to put a minus in that first parenthesis in between the x and the 2. Maybe. There we go. The second sign is the opposite of that. So the opposite of a negative is a positive. And my pen is not wanting to write again. And then the third sign is always positive. Now, do you know how when we did the perfect squares that sometimes we could break some of them down again? We need to check and see if we can break anything down. However, when we are looking at these, this second part, come on, this trinomial right here, that will never be able to break down and factor, so there's no need to even try. So the only part we really look at is that first parenthesis, x minus 2. It is 2 terms, which means we can only factor if they're both perfect squares still or both perfect cubes. Is x a perfect square or a perfect cube? No. So then therefore I cannot factor this any further, which means my answer is just this right here. Okay, so if any of this continues to factor, it will only be the first parenthesis. The second parenthesis will never break down any further. I want you to try number 2, using the same process. Okay, always ask. 0.484. Ask yourself, do you have a GCF? If not, are they both perfect cubes? If so, figure out what your A value is, what your B value is, and plug those values into your pattern. Then you place your signs with SOAP. Same, opposite, always positive. Do we have a GCF for this one? Do x to the third and 27 have anything in common? No. Are they both perfect cubes? Yes. So I'm going to start by writing my A and B values. What is the cube root of x to the third? X. Oh, sorry. The pen is not wanting to write again. And what is the cube root of 27? 3. All right, first parenthesis, it is A and B. Second parenthesis is A squared. A times B. And if I take 3 and square it, I get 9. And then same, opposite, always positive fills in my signs. Same, opposite, always positive. Just check. Can x plus 3 factor any further? No, they're not perfect squares or perfect cubes. So that is how we leave our answer. As long as you know your pattern, these are not hard, especially if you have a list of cubes to look at. If you're not familiar with them, you have a list. You can use that list on your test next week. I want you to try 3, but there is a very common mistake that happens in question number 3 that I will point out once we go over it. I just want to see if any of you make it. Remember, if you're not sure about your perfect cubes, you can look to your list, find the number on the cube list, scroll over to the roots, and that tells you what the cube root is. Do 64x to the third and 27 have anything in common that I can pull out? GCF? No. Are they both perfect cubes? Yes. All right, so let's figure out A and B first. What is the cubed root of 64x to the third? 4x. And what is the cube root of 27? 3. All right, so in my first parenthesis, it is just my A value and my B value. A is 4x, B is 3. Here is where the mistake happens, and a lot of you made it. Okay, that's why I'm making sure to point it out. If I take my A value, 4x, and I square it, that means I multiply it by itself, yes? 4x times 4x is not 4x squared. It is 16x squared. So when you have that number in your A value, it also has to be squared. 4x times 4x is 16x squared. Okay, so if you put 4x squared wrong there, that's wrong. Keep in mind, if I were to check my work and to multiply this stuff back out, hold on. Multiplying these two, if my pen, those two, the 4x times the 16x squared should give me 64x to the third. If I multiplied 4x times 4x squared, that only gives me 16x to the third. So just be careful with that, okay? All right, then we're going to do A times B. 4x times 3 gives me 12x. And then 3 squared is 9. Come on. This tablet is not wanting to cooperate with me today. There's supposed to be a 9 there if it would let me write it. Oh my goodness. Hold on. I'm trying to write my 9, y'all. Sorry. Finally. And then my signs. Same, opposite, always positive. So what goes first? Plus, and then, ooh, that's ugly. Then a minus, and then the third one is always positive. And then we just check the beginning. Does 4x plus 3, can that factor? Are they perfect squares or perfect cubes? No. Okay, so be very careful with that. Are we ready for 4? Here's a hint. These have a GCF you need to pull out before they're cubes. Because 4 is not on my perfect cube list, is it? So pull your GCF out first, then continue to factor. Go ahead and try. There is a GCF that you're going to have to pull out first before you have 2 perfect cubes that can factor. Keep in mind, when you pull out a GCF, you do not just make it disappear. It is going to be in the front of whatever you factor. What is it that 4x to the third and 4 have in common? A 4. So we need to factor out that 4 first. Maybe. And if I divide both of those by 4, I'm left with x to the third minus 1. Now, if you look inside your parentheses, x to the third minus 1, are those both perfect cubes? Yes. So we can continue to factor. I'm going to list my A and my B. A is the cube root of, what is the cube root of x to the third? X. And B is the cube root of 1, which is just 1. And when I go to break down and set up my two parentheses, I'm just going to put the 4 in the front. Again, in my first parenthesis is just A, then B. We said A was x. We said B was 1. Then it is A squared. X times x is x squared. Then it is A times B. X times 1 is 1x. If you want to put the 1 in front of that, you're welcome to. And then B squared. 1 squared is just 1. And then I have same, opposite, always positive. And that does not factor any further. So keep in mind, if you pull out a GCF, you have to leave that in front of your parentheses of what you break down further. No, I don't worry about the signs until the very end. Yeah. All right, I got one more for you. I want you to try that one. Keep in mind, we're looking for a GCF first. Because right now, the terms that I have, 2x and 16x to the fourth, are not perfect cubes. Also, remember when we discussed our perfect squares, we talked about not rearranging our terms. Variables can stay in the second term. They don't always have to stay in the first. What is it that 2x and 16x to the fourth have in common? A 2 and x. So we're going to need to pull both the 2 and the x out. And if I do that, 2x divided by 2x is 1. Plus 16x to the fourth divided by 2x is going to be 8x to the third. If you don't pull that x out, you don't have cubes, so you can't factor. Are 1 and 8x to the third both perfect cubes? Yes. Okay. So let's list our a and our b. A is going to be the cube root of 1. What's the cube root of 1? Sorry, I'm trying to fight this tablet again. Let's try crazy. I'm going to do it up here. So we've got the 2x, and then we've got 1 plus 8x to the third. So again, my a value, what's the cube root of 1? What's the cube root of 8x to the third? 2x. Okay. Now remember, this original 2x that we pulled out stays in the front. We're going to set up our 2 parentheses, and we're going to follow our pattern. A and B, so 1 and 2x, and yes, it's okay for that 2x to be in the back. I'm going to leave it in the order it is in the problem. Then it is a squared. 1 squared is 1. Then it is a times b. 1 times 2x is 2x. Then it is b squared. Be careful with this one. 2x times 2x is not 2x squared. It is 4x squared. And then we can fill in our signs. Same, opposite, always positive. This does not break down any further. Therefore, that is as far as we can take it. So in this particular problem, it would be okay to switch it because it's a plus. But if that were a minus, you can't do that. So let's try not to get in the habit of moving it around. Just leave it as it is. Okay? Does everybody understand that? If this were a minus sign here, rearranging it would not work. Okay? So let's just get in the habit of leaving it in the order. Whatever the first term is, that's your A. Whatever the second term is, that's your B.